What's up, 2K gamers? Mr. Cully coming at you, and I am not happy. Why? Because I just recorded this video. It took like 20-something minutes, and then it didn't save, so I got to do it again. So I'm doing this for you, okay? I love you all. Here we go. We're talking about Sig Figs today. Sig Figs. What are Sig Figs? That sounds so weird. Well, it's this thing that you get introduced to in freshman year that is kind of nerdy, kind of mathy, kind of science, and you're like, when am I ever going to use this in life? And I would say, good point. You're going to use it when you take chemistry your junior year or physics your senior year. If you go to college and you take like a really nerdy science class, you'd be like Sig Figs. But really, other than that, you're never going to use it for the rest of your life. But I got to quiz you on it anyway. I'm sorry, but let's go and talk about what sig figs are. What even is a sig fig? Do I eat it? No. A sig fig stands for significant figures. I'm like, that doesn't help. I don't know what that is. It also stands for significant digits. You're like, well, I kind of know what a digit is. And isn't that something about a number? And I would say, yes, it does have to do with a number. So I'm going to kind of introduce you to what this whole significant digit, significant figure, sig fig thing is. And then it's going to kind of make sense to you, even though you're going to be like, I'll never use this. You'll be like, I got this. But let's go ahead and dive in with an example. So to help you understand what a sig fig is, let's look at this scenario. You and your friend Bob each measure the length of the same pencil. You measure it to be 8.73 centimeters. Bob measures it to be 8.734121 centimeters. Okay, you're like, okay, Bob, you're a little try hard, okay? But why is that number different than your measurement? Well, because Bob went out to more decimal places. He's just like, well, I know for a fact that it goes out to 8.734121. You're like, okay, whatever. I don't really care that much. Okay, good for you. But the thing is, these numbers have significance. Whoa, these digits have significance. Why? Because it shows that the number has precision to it. He knows for a fact that it's 8.734121 centimeters. You only know it's 8.73. After that, we don't know, okay? But he does. So we would say that those digits have meaning. They have a significance to them, all right? So let's look at another example. You and a friend Sally, okay, each measure the length of the same eraser. You measure it to be 2.1 centimeters. She measures it to be 2.1000 centimeters. So what's the difference between those two numbers? 2.1 is 2.1. Correct, okay? But here's the difference. If there are zeros after that, in the decimal place, after the decimal place, that's telling you precision. Again, the whole key to this is precision. How precise is my number? Well, to understand this, 2.1 is 2.1. However, the fact that Sally has these zeros after the 1, they actually show precision. She knows that it's 2.1000 all the way out to that decimal place. So she is more precise with her answer than you are, okay? Even though they're the same number technically, the fact that she goes out more decimal places means that it's more exact. And so we would say that these zeros have meaning or they have significance. All right, so you're starting to see that the whole idea of sig figs is that some numbers are more precise than others, and therefore they have more significant digits to them. All right, so what we're going to do, we are going to count the amount of significant digits within a number. Okay, that's important because when we take measurements, we're going to have to use like multiplying them, adding them, that kind of thing. It's a lot of fun. But let's go ahead and learn a couple rules about counting the number of sig figs within a number. All right, there's two rules. There's the Pacific rule and there's the Atlantic rule. You're like, I've heard of those before. Yes, the oceans that surround the United States. On the left side, on the west coast of the United States, we have the Pacific Ocean. It's kind of cold. No one likes to go in it because it gets that Arctic current, and it's just not fun to be in. But on the Atlantic side, on the right side, on the east side of the U.S., we have warm water. That's where you go to the beach. You go to Hilton Head, Myrtle Beach. You go to the Outer Banks. That's where I was this summer. All right, that's the place to be. But the whole point that I want you to know is that the Pacific's on the left side and the Atlantic's on the right side. Why? Because we're going to use that information here in a second. All right, the first rule that we need to know when counting the number of sig figs within a number is the Pacific rule. Pacific starts with P. You know what also starts with P? Present, okay? So whenever there is a decimal point present within a number, we are going to use this rule. And I'm about to throw a lot of stuff at you, okay? I want you to soak it in, and then we're going to take these rules and we're going to apply it to some examples. So right now, it might not make that much sense, but it will here in a second when we kind of use some examples. So the Pacific rule, we use it when the decimal point is present. And what we're going to do is we're going to start from left to right in that number, okay? From left to right, we are going to start. We're going to move from left to right until we hit the first non-zero digit. So what does non-zero mean? That means that the number is not zero. So from left to right in a number, you're going to look for the first digit that's not zero, all right? And then what you're going to do is you're going to count the number of digits, including that number and everything after that. That's going to give you the number of sig figs in that number. You're like, Cully, I don't know what you just said. I'm like, I know, me either. However, let's look at some examples and kind of take it step by step. So if I asked you how many sig figs were in these numbers, all right, we would be using the Pacific rule to determine how many. Why would we be using the Pacific rule? Well, because if you notice, all of these numbers have a decimal point in them, aka the decimal point is present, it's present. So Pacific rule starts with a P, so does present, okay? Well, what does that mean? That means that we are to start at the left side of the number. Wait a minute, the Pacific Ocean's on the left side of the US. Exactly! That's why it's called the Pacific rule. So what we're going to do is we're going to start at the left side of all these numbers, okay? What are we going to do on the left side? We are going to count the number of significant digits. Well, how do I know where to start? You start at the first non-zero digit you hit. Okay, fair enough. So looking at this number from left to right, I go until I hit my first non-zero digit. 0, okay, 0.0003, woo, that's my first non-zero digit. So that number and everything after that now, from left to right, is going to be considered significant. So in this number, how many significant digits do I have? I have 2, okay? 2 numbers in this, 2 digits in this number are significant, okay? To recap, from left to right, you go until you hit your first non-zero digit, then that digit and everything after that is significant. Let's look at the next one, okay? 21.453. From left to right, I'm going to move, okay? I go until I hit my first non-zero digit. Well, it's right off the bat, this 2. So this makes it easy. That 2 and everything after that, I don't care what it is significant. So how many significant digits are in this number? 5. All right, let's do it again. 0.02340. All right, looking at this, I move from left to right within the number until I hit my first non-zero digit. It's this 2. And now everything after that, including that N0, is significant. Doesn't matter what comes after it. It doesn't matter if it's a 0. Everything after that is now significant. Why would that 0 be significant? Because it shows precision. It shows that you know that this number is that number all the way out to that decimal place. Okay? Just follow the rules. Just be a rule follower. All right, this next one. 736.00. Okay? I move from left to right. Here's my first non-zero digit. Now everything after that is significant. 5 of them. Okay? And that one. Next number, final number, from left to right. All right? We are going to work. First non-zero digit we hit is the 6. And now everything after that is significant. All 6 of those digits are now significant. All right? So that is the Pacific rule. Whenever there's a decimal point, you go from the Pacific Ocean side of the number, aka the left side, and you work your way from left to right. You look for your first non-zero digit, you hit it, everything after that is significant too. All right, so that's the Pacific rule. So I wonder what the Atlantic rule is. The Atlantic rule is when the decimal point is absent. If you're not present, you're absent. So the Atlantic rule, Atlantic starts with A, absent starts with A, Atlantic absent. You just do the opposite. You start at the right side of the number, okay? You work away from left to right until you hit your first non-zero digit. And then from that point on, from left to right, right to left, everything is significant, all right? So let's take a look at what this looks like with this, all right? Atlantic rule. Why are we using the Atlantic rule with all these? Well, because the decimal point is absent in all of these numbers. If you look, there's no decimal point in 12 or 350, okay, or all those. So whenever there's not a decimal point, what we're going to be doing is we're coming from the right side of the number. The right side. Look at my arrows. Yeah, you can tell I went to college. Look at those, okay? Your parents will probably watch this and be like, this is your science teacher? Oh my gosh. So from right to left, you're working this. The 2 is the first non-zero digit we hit. Now everything after that from right to left this time is significant, okay? So you're just kind of going the other way. So 12 has 2 significant digits in it. Well, what about 350? Well, from right to left, this time the first non-zero digit I hit is actually this 5. And then everything after that, from right to left, is going to be significant. So 350 has 2 significant digits in it. All right, 19,303. How many are in that one? Well, the first one we hit is this 3. Now everything after that is significant, all 5. What about this one? 230,001. Well, from right to left, the first number you hit is non-zero, so that and everything after that is significant, all 6 of those. All right, what about 230,000? Well, these numbers are very similar than the one above, but we can see that we don't hit our first non-zero digit until the 3 here. So this one actually only has 2 significant digits. You're like, that wasn't so bad. Or maybe you're sitting there like, I don't know what's going on. That's fine. But understand, this is how you go about it. These are the 2 rules we're going to use to count the number of significant figures in a number. All right, so that's day 1. That's the intro. What I'm about to go in is kind of getting a little bit tougher. All right, so now that we know how to count significant digits, what we're going to do is we're going to start rounding numbers to a certain number of significant digits. You're like, I don't know what you just said. I'm like, I know, but we're going to get it. Okay, so let's take a look. I'm going to skip this. If you were asked to round a number to 3 sig figs, would you ask yourself, you would ask yourself, what is the closest number I can get to the original number that only has 3 sig figs? So for example, you're given the number 12.76, all right? And I ask you to round that number to 3 sig figs. You're going to ask yourself, what is the closest number I can get to 12.76 that would only have 3 sig figs? Because right now, 12.76, that has 4 sig figs in it. All right, why? Because of the Pacific rule, okay? 1, 2, 3, 4. I need to ask myself, what is the number closest to 12.76 that I can get that only has 3 sig figs? All right, so think about it. What number is the closest number to that with only 3 sig figs? Very good. It is 12.8. Very good. Why? Because if you've ever learned rounding before, you would know that 5 and above, give it a shove. That 6 bumps up that 7, and so I could say 12.8. 12.8 is pretty dang close to 12.76, and it's only got 1, 2, 3 sig figs in it. All right. So if I'm rounding a number, if I'm asked to round a number, the question I'm asking myself is, what is the closest number I can get to the original number that only has this amount of sig figs? Okay. In this case, I was rounding the number to 3 sig figs, so it's going to be 12.8. All right. Why wouldn't it be 12.80? Good question. Think about it. That would be 1, 2, 3, 4 sig figs. Can't do that. All right. Why wouldn't it be 12.7? Well, because 12.8 is actually closer to this number than 12.7 is, because that 6 makes it closer. So the only answer that is the closest one to that would be 12.8. All right. So let's look at some examples. Let's just do the first 5 on the left. Let's not do these. What is the closest number I can get to 32.56 that only has 3 sig figs? Well, right now this number has 4, so I need to get rid of 1. How am I going to get rid of 1? Well, I could drop this 6 and make it 32.5. All right? But because that's a 6, it's actually going to bump up that 5 right there. So this, the closest number I can get to this that only has 3 sig figs would be 32.6 actually. Because remember, 5 and above, give it a shove. So the closest number to 32.56 that has 3 sig figs is 32.6. All right. What about 0.9824? All right, fair enough. I could just drop off that 4, right? If I drop off that 4, I'd only have 1, 2, 3 sig figs. And guess what? You would be correct. That's all that you have to do for this one. Why? Because that 4 is not big enough to bump up that 2. 5 and above, give it a shove, not 4 and above, okay? So the number here that is closest to this number would be 0.982, okay? And that only has 3 sig figs to it. Well, what about this next one? 2.4099. Okay, that number's got 5 sig figs, so we need to round it to 3 sig figs. All right, what's the closest number to this one? It would be 2.4, then what? Well, I can only add one more number. What number would it be? It could either be 0 Or because that's a 9, that can bump up that 0. And so it'd be 2.41. So the closest number I can get to 2.4099 is actually 2.41, and that's got 3 sig figs in it, which is what I want. Well, what about this next one? This next one is very similar to the number above, but what's the difference? Well, just like before, I got to figure out it's going to be 2.4 something, right? But then what? What's my next digit going to be? Well, before I had a 9 that was able to bump it up. That 4 cannot bump up that 0. So what I have this time is just 2.40, okay? And that has 3 sig figs to it. And then lastly, 9,875. 9,875, that has 4 sig figs in it, and I need to bump that up, round it to 3 sig figs. But this 5 can bump up that 7. Right? 5 and above, give it a shove. So my answer is actually be 9,880. You're like, whoa, that's kind of weird. I'm like, yeah, it is weird. The closest number I can get to 9,875 that has 3 sig figs is 9,880. You're like, wait a minute, that's got 3 sig figs? I'm like, yes, because notice, this number does not have a decimal point, so you come at it from the Atlantic side. So this one would only have 3 sig figs in it. You're like, wouldn't it be 988? I'm like, well, I mean, you're right. 988 only has 3 sig figs. But which number is closer to this? 988 or 9,880? And you're like, oh, I see. 9,880 is the closer number to 9,875. All right. So weird stuff. I know. Weird stuff. Okay. So that's rounding numbers to a certain number of sig figs. There's one last thing we're going to talk about, and that is multiplying and dividing with sig figs. All right, so here we go. This is the final thing. Let's say that you're given 2 measurements, okay, 2.42 and 5.3. All right, if you multiply them, here's the rule. You have to count the number of sig figs in each number you are multiplying or dividing. All right, fair enough. I can do that. 2.42, that has 3 sig figs in it. 5.3, that has 2 sig figs in it. And I'm blocking it. That's great. Well, where do we want to put me? Right up there. Okay. So now what I'm going to do is I'm going to calculate it like normal. Put it in my calculator. And what I'm going to notice is that my answer is 12.826. How many sig figs are in my answer? 5. That's way too many. How did I get 5 sig fig? How did I get a 5 sig fig answer? But the 2 measurements that I used were 3 sig figs and 2 sig figs. That doesn't make any sense. I'm like, well, the math is right, okay? However, how could I have a more precise answer than the 2 measurements that I had? The answer is, in science, you're not supposed to. So what we got to do is we got to round our answer. Well, what do we round it to? We round our answer to the least number of sig figs in the problem. So I would have to round my answer to whatever my lowest number of sig figs were. Well, in this case, in this problem, I had 3 sig figs, 2 sig figs. 2 sig figs is the lowest number of sig figs I had in the problem. So unfortunately, that means that I got to round my answer to only 2 sig figs. So what's 12.826 rounded to 2 sig figs? It'd be 13. Okay. Why are we doing this? Understand, if you have 2 measurements, 2.42 and 5.3, and you multiply them, your answer can't be any more precise than your least precise measurement. It doesn't make any sense. You can't get a super precise answer from having not super precise measurements. So what we have to do is we have to round our answer to the least precise number that we have in our problem. In this case, it was 5.3. That had 2 sig figs, so our answer must be rounded to 2 sig figs. All right, so let's take a look at some examples. And then we're done. I know. It's terrible. 4 times 11. All right, 4 times 11 equals 44. You're like, wow, I feel like I'm in 3rd grade. I'm like, I know. Okay, 4 has 1 sig fig. 11 has 2 sig figs. 44 has 2 sig figs. Okay, well, in my problem, I need to round my answer, 44, to the least amount of sig figs I had in the problem. So what's that in this case? Well, 4. 4 only had 1 sig fig, so that means I got around 44 here to 2 sig fig, or sorry, 1 sig fig. So what's 44 rounded to 1 sig fig? What's the closest number I can get to 44 that only has 1 significant digit in it? And the answer is 40. Okay? 40 only has 1 significant digit. Coming at it from that side, that 4 is the only significant number in it. So the closest number I can get to 44 that only has 1 significant digit is 40. And so using significant digit rules, my answer would be 40. All right. Next one. 6.75 divided by 3.0 equals 2.25. Again, you count the number of sig figs in your measurements. Here, 6.75 has 3 sig figs. 3.0 has 2 sig figs. All right. So that means I need to round my answer here, the 2.25, to only have 2 sig figs in the problem. Why? Because that's the lowest amount I had between my two measurements. So what's 2.25 rounded to 2 sig figs? Well, that 5 can bump up that 2, and my answer then would be 2.3. 2.3 is the closest answer I can get to 2.25 that only has 2 sig figs. All right. We're not going to do the next one because I'm not going to ask you one like that. 52 divided by 9.63. Well, in this case, 52 has 2 sig figs. 9.63 has 3 sig figs. So I'm going to round my answer to 2 sig figs. And so here, 5.399792, that's got a ton of significant digits in it. I only need 2 though. So what's the closest number I can get to this that only has 2 sig figs? Well, that 9 can bump up that 3, so I just have 5.4. And lastly, 1.340 times 3.5. All right, taking a look at this. This first number's got 4 sig figs. The second number has 2 sig figs. So I need to round my answer to only have 2 sig figs. So 4.69 becomes, and 9 could bump it up, 4.7. Okay. Really, really weird stuff, I know. You need to understand it because in 2 years, 3 years, when you take another science like chemistry or physics, if you decide to go that route, you're going to have to learn this. And especially if you go to college, you're going to have some professor that's a stickler on the stuff, and they're going to be like, well, why in the world? I'm going to be like, I know. Okay. But I need to prepare you for this so that you know what's coming on down the road. If you have questions, let me know. But other than that, that is what I want you to know for sig figs in general. But that's going to be it. Let me know if you have any questions.